Hello students, welcome back. Let's resume section 3, limit computation. Previously we discussed the trivial limits, not very important. 0 over 0 type limits, very important. And one-sided limits, moderately important. Now the final topic is infinity over infinity type limits, and this one is equally as important as 0 over 0 type limits. Note that both are in fraction forms. We're done with 0 over 0 type, so let's discuss infinity over infinity type. Among them, the easiest of the bunch is the rational function, the polynomial of a polynomial, and in this case we are looking for the horizontal asymptote of the rational function. How do we do that? We take the asymptotic estimation, like this. Just take the leading terms, the highest degree terms only, and disregard the rest and simplify. As you can see, you get y equals to 2. That is the horizontal asymptote, and also that is the limit value. Now, here is a wrong solution. What's the difference between the two? We have the same answer here, but this is right and this is wrong. Why? Here we have limit notations. Here, no limit. That's why the second expression is wrong. We have three expressions here, blue, red, and green, and they're all different quantities. They are not the same, but they all share the same end behavior. So upon taking the limit, they all became the same, and that's what we have over here. That does not mean these three are same quantities. So without the limit, they are not the same. With the limit, they are the same. So this is a wrong solution. If you do it like this, probably 7 out of 10, maybe 8 out of 10 if I'm in good mood. Okay, so much for the simplest type. Now, what if we have some radicals flying around? In that case, you have to find out the degree of numerator and the degree of the denominator accurately. Degree, or the growth order, when you have radical, how do you do that? Well, my first question here, what is the degree of the numerator? The highest degree term here is x squared. Do you see that? The growth degree is x squared in numerator. Wait a minute. We have higher degree like x to the fourth power and third power. Why not those? Because those are inside the square root, so square root means we have to divide by 2. If it is cubing root, I have to divide the power by 3. So this is square root, so dividing by 2, well, this is second power. And this one is 3/2, so 1.5 power. All these are less than second power. All these are less than second power. Now, how about the denominator? Got the answer? Not yet? Stop the playback if necessary. This is how you do it. Take the highest degree terms only and disregard the rest. Please note that x to the fourth power here is equivalent to x to the second power. This second power is just first power, so it's out. The third power is 1.5 power, so that's out. The second power is out, and so on. So this is what we get. And square root of 4 is 2. Square root of x to the fourth power is x squared, so we get the second expression like this. And then further simplifications yields this and that. We get y equals to 1. And here is the graphical justification. Y equals to 1 is indeed the horizontal asymptote. So how do we handle radicals? Find out the growth order precisely. Square root, then you have to divide by power 2. Square root means divide the power by 2. Cubing root means divide the power by 3. Fourth root, divide the power by 4, and so on. In practice, I don't think you're going to meet really complicated radical. Probably about square root, that's about it. Maybe cubing root. Alright, here's another problem, and looks like this can be a good exercise for you, so please stop the playback and go through. So what do you have here? Did everybody get the answer? Okay. That's out. And that's out. And that too is out. We have growth order of 1, degree of 1. So second power inside of the square root. So dividing by 2, we get first power. Okay, we get that. And then let's simplify this. And square root of 2 is square root of 2, nothing more. So this is x, because x squared inside of the square root comes out as just x. And then if you cross out all the x's, what do I get? Am I going to get square root of 2? Looks like it. Is that right? No. Something is wrong. Correct it. What did I do wrong? Up to here, everything is right. So something wrong took place at the very last moment. If I cross out all the x's, crossing this x out is okay, because cross out, you get 1. Times 1 will not change anything. Cross out, then you get 1. Dividing by 1 will not change anything. Cross this one out, we get 1. Hey, where's 1? I missed it. There you go. That's the correct answer. As a matter of fact, it should have been like this. This x goes out, we only have square root of 2. And this goes out, we have 1. That goes out, we have 1. And then dividing by 1 doesn't change anything, so remove that. Now, let me just take extra step. And there goes the answer. Just crossing those out and then getting square root of 2 was one of the common mistakes, as a matter of fact. Here's the correct solution. As a matter of fact, it's better if you factor x out and then cross out. Alright, so far so good. We have one last problem here. How about this? Well, let's keep it as big a font. It's easier to read. Stop the playback and go through. What do you have? Looks like we're going to get the same answer as before, right? Exactly the same computation. Throwing away unimportant terms and get those out. But then again, why did I mark it as a wrong solution? What is wrong with this so that this is a wrong solution? Found out? Where's the mistake? Okay, here's a hint. If you graph it, then you'll see you have two different y-intercepts. Not y-intercepts, excuse me. Two different horizontal asymptotes. So this one here, green one, that is the computation we just did. We want the red one because we are going to the negative infinity. So something is wrong. How do I correct it? The answer is right here. When you get x squared out of the square root, it became negative x. Why? X is going to negative infinity, so x itself is negative. So if I just get x out of there, then square root of x, this entire quantity becomes negative, but that should be positive. So how do I make a certain quantity, certain negative quantity into positive? By putting an extra negative sign. By that extra negative sign, this becomes positive. Let's look at this solution here. This quantity here is negative because x is going to negative infinity. This entire thing. This quantity should be positive because positive square root, and then of course x squared is always positive. So this is positive. This red is positive. But this red is negative. Something is wrong. How do I make it right? By putting an extra negative sign. Now it is correct. And then from here, we can do some algebraic manipulation or simplification. Crossing all those x's out, negative square root of 2 minus 1 over 1. So we get negative square root of 2 minus 1. There you go. That's negative square root of 2 minus 1. The red horizontal asymptote versus green horizontal asymptote. The last subtlety about sign change there, what can I say? I wouldn't say it's impossible or chance is 0, but I have to admit that there is relatively low chance that you're going to see that in the exam. Even if you do see it, missing that sign will not give you any more than 1 point off. So don't be too intimidated and don't worry too much about it. Still, overall, infinity over infinity type limit computation is important. And it's a bit harder than 0 over 0 type. We just went through it. That'll complete section 3, and we'll meet again in separate video for sections 4 and 5.